Professor Belfrost's science class is back.
Hi everybody, welcome back to my class, to my tutorial. Today I will bring you new course and today I choose chemistry and yeah, because this is the first course on chemistry, of course I will start from the basic of the chemistry. But if you want just the definition of chemistry, I suggest you not watching this video because I will not give you the definition, the formal definition of chemistry. You can just search it at Wikipedia or whatever. Okay, because here we will start our first lesson on matter, physical and chemical properties, elements, and compounds. The first video. Yeah, this is a very wide topic. I mean, yeah, you learn it first in your class. I think this is the first lesson that you have in your class, but this is still very, yeah, there are many of them. So I will divide this topics. I'll separate it into maybe 3 or 4 videos, and this is the first one. And today I'll focus on explaining matter. Okay, so chemistry is full of, uh, like reaction, change of matters, whatever, rearranging matters, substances, compounds, solutions, reagents. And actually, the basic of chemistry is matter. So what is matter? Matter is defined as anything that has mass and occupies space. Mass. Mass characterizes an object's resistance to a change in its motion. Inertia. This is just a scientific term, inertia. And space is that which is occupied by matter. So by definition, space only exists if there is matter. If there's no matter, there's nothing, then you cannot say that there is space there. Okay, so actually the entire universe made of two things, matter and energy. Okay? In chemistry we cover that too, matter and energy. According to its states, matter may be categorized into solid, liquid, gas. These three states occur at room temperature, and plasma Bose-Einstein condensate. These two occur exist at extreme temperature. One is very hot and one is extremely cold, okay, near absolute zero. But actually, there are more kind of matters that actually scientists have defined, but I will not cover that in this episode because it's not very widely known and it has nothing to do with our chemistry class. In chemistry class, even we don't need to discuss about plasma and Bose-Einstein condensate for you beginner intermediate level because we only focus on these three: solid, liquid, gas, and later we have the state of aqueous. What is aqueous? You will see when we start at the lesson of stoichiometry, whatever, they will have that kind of aqueous state. Okay, so first solid. If I'm talking about solid, it's very clear, right? Solids have a definite shape and a definite volume. Okay, so in a solid, the molecules are close together. Yeah, it's very compact and connected by intermolecular bonds. So solids can be amorphous, meaning that they have no particular structure, or they can be arranged in crystalline structures or networks or lattices. Let's see example. Okay, so soot, graphite, and diamond are all made of the same element, carbon, pure carbon, and they are all solids. They exist in solid state. Okay, soot is amorphous, so the atoms are randomly stuck together. Graphite forms parallel layers that can slip past each other. That's why I call lattice. Diamond, however, forms a crystal structure that makes it very strong. Okay, so the brittleness of something actually depend on how the arrangement of the atoms in that object. Okay, the second state, liquid. Okay, so liquids have a definite volume, but they do not have a definite shape. Instead, they take the shape of their container. If there is no container or vessel, then the shape is determined by other internal or external forces. In zero gravity, okay, notice that in zero gravity, that liquid assume a spherical shape. Okay, you can see it when you watch a slow motion video of maybe the activity inside uh, any spacecraft or whatever in ISS. Okay, if you watch that video, you can see that the liquid has maybe not a perfectly spherical shape, but nearly spherical shape. Okay, but it will resonate. Yeah, it will resonate, but will reach spherical shape. Okay, so the molecules are close, but not as close as a solid. The intermolecular bonds are weak, so the molecules are free to slip past each other, flowing smoothly. So there's a property in liquid that's called viscosity. Okay, viscosity is just the measure of thickness of the liquid when flowing. Okay, the example are, the example is water. For example, you know water. Water is not nearly as viscous as molasses or syrup or whatever. Yeah, water can flow easily. I mean, it's not thick. Okay, both liquid and solid samples have volumes that are very nearly independent of pressure. Next, gas. This is the third state. Okay, so gas particles have a great deal of space between them and they have high kinetic energy. Even confined, the particles of a gas will spread out indefinitely. But if confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of the container, the space between particles is reduced and the pressure exerted by their collisions increases. Yeah, so they have high thermal energy, high kinetic energy. The temperature increases. We'll see there are laws that define this. Okay, if the volume of the container is held constant but the temperature of the gas increase, yeah, the pressure will also increase. Yeah, because there are more internal energy in the system. Okay. Gas particles have enough kinetic energy to overcome intermolecular forces that hold solids and liquids together. Thus, a gas has no definite volume and has no definite shape. Yeah? There are many kind of gases. Okay. For example, the one that we use to breathe, oxygen. Also, the one that maybe you also use when you want to pump tire or whatever, nitrogen, helium, hydrogen, also all gases. Okay, you can see the picture. Okay, solid, liquid, and gas. Okay, so now we enter a not very ordinary state. Yeah, but maybe you have ever heard. I think plasma is quite general. You have heard it sometimes, many times maybe. So plasma is actually gaseous state of matter that contains appreciable numbers of electrically charged particles. Why? Because it exists in very high temperature. That's one cause. Okay. Plasma is not a common state of matter here on Earth, but for example for space, star, yeah, this is very common. Okay. But this is the most common state of matter in the universe. Plasma consists of highly charged particles with extremely high kinetic energy. How to make a plasma? You can make it by, okay, splitting grape and inserting, yeah, putting it in microwave. Then you can create plasma actually if you want. Yeah, you can watch many YouTube videos about it. For example, the noble gases like helium, neon, argon, krypton, xenon, radon are often used to make glowing signs by using electricity to ionize them to the plasma state. Stars, yeah, the second example, stars are essentially superheated balls of plasma. Okay, then the fifth state, a BEC, Bose-Einstein condensate, okay, exists when matter is frozen to extremely low temperature. They are a tiny fraction of a degree above absolute zero, 0 Kelvin. Okay, in this state, the atoms overlap into each other to form a wave. The BEC is a matter wave. If the wave was compressed, it will form a singularity. What's a singularity? A very very tiny space that hold very great mass, that singularity. Okay, if enough mass was condensed into the singularity, it could turn into a black hole. The occurrence of a black hole while making BC would not need to be too much of a concern anyway, because it would require a tremendous amount of energy to advance into a critical point. Okay, so now we are talking about the classification. Okay, so matter can be classified first according to its composition. Then there are two broad categories: one, pure substance, and second, mixture. Okay, the first one, pure substance, can be divided again into elements and compounds, while mixtures can be divided into homogeneous and heterogeneous mixtures. Yeah, you can see the picture. Yeah, so mixture can be separated by physical methods to make a pure substances. Yeah, for example, what? Say evaporation, filtration, whatever. Yeah, there are many. We'll learn later in maybe two or three next videos. Okay. Also, compounds can be separated by chemical methods to obtain elements. Okay. Okay. So first, a pure substance. Okay, a pure substance has a constant composition. All specimens of pure substance have exactly the same makeup and properties. For example, any sample of sucrose or table sugar consists of 42.1% carbon, 6.5% of hydrogen, and 51.4% of oxygen by mass. Any sample of sucrose also has the same physical properties, such as melting point, color, and sweetness, regardless of the source from which it is extracted or isolated. Okay? Pure substances that cannot be broken down to simple substance by chemical change are called elements. Okay? There are many elements. Yeah. Some exist purely independent, some exist maybe in compound state and in others. Okay, for example, iron, sulfur, gold, aluminum, sulfur, oxygen, copper. Okay. And there are second category of pure substance, right? Okay, so pure substance that can be broken down by chemical changes are called compounds. Okay, this breakdown may produce either elements or other compounds, or maybe both. For example, yeah, first, mercury to oxide, yeah, an orange crystalline solid can be broken down by heat into the elements mercury and oxygen. Okay, because mercury oxide. Okay, mercury and oxygen. We'll learn this later. The second example, the compound sucrose. Okay, sucrose. When heated, why I type ahem. Yeah? When heated in absence of air, will be broken down into the element carbon and the compound water. Okay, the initial stage of this process, when the sugar is turning brown, is known as caramelization. Yeah, maybe you love having caramel candy, maybe. Yeah, I love it too. The second, the third, yeah, third example is silver one chloride. Yeah, it's a white solid that can be broken down into its elements silver and chlorine by absorption of light. Yeah. The properties of combined elements, yeah, this is a very important thing to note. The properties of combined elements are different from those in a free or uncombined state. Properties, every properties, color, um, yeah, color, and then boiling point, and then yeah, the physical, also what the taste, the yeah, anything, the combustibility, yeah, basically anything. For example, jump to the example. White crystalline sugar, sucrose, is a compound resulting from a chemical combination of carbon, which is a black solid in one of its combined forms, and two elements of hydrogen and oxygen, which are colorless gases when uh, uncombined. Okay, and yeah, you know that maybe you have a sucrose in your syrup or whatever in your drink, anything that you consume daily, and it tastes sweet. Hydrogen and oxygen don't taste sweet. Carbon also don't taste sweet, and also the color is different, right? Okay, so yeah, that is chemistry. The second example is free sodium, an element that is a soft, shiny metallic solid, and when combined with free chlorine, an element that's a yellow-green gas, you have sodium chloride, your table salt, a compound that is white crystalline solid. Okay, so we are done with pure substance. We now enter mixture. Okay, so mixture is composed of two or more types of matter that can be present in varying amount, can be separated by physical changes. Okay, so I also say that there are two kind of mixture. Okay, first is heterogeneous, mean that the composition varies from point to point. Yeah, for example, yeah, this is just a very uh, general example. Italian dressing. Yeah, maybe you love Italian dressing. Yeah, which composition can vary because we can make it from varying amount of oil, vinegar, and herbs, but we still call it Italian dressing, right? It doesn't change the name. Yeah? It may not be the same from point to point throughout the mixture. Also, everyone can make it differently. Yeah, yeah. Maybe one drop may be mostly vinegar, whereas different drop may be mostly oils or herbs because the oil and vinegar separate and the herbs settle. Okay, second example, yeah, chocolate chip cookies. Who loves chocolate chip cookies? Yeah, but what I mean here is just the dough. Okay, the dough of chocolate chip cookies. Yeah, when we separate them, they are chocolate nuts. Yeah, the flour, anything inside the composition, the ingredients. Yeah, every part of the cookies have different um, percentage of the composition. Okay, the third example, granite. The granite, we can see that quartz, nickel, feldspar, more, yeah, kind of minerals that, yeah, combine together to create granite. It's still called granite, yeah, but one granite to the other granite that you have may be different in quantity of the quartz, mica, feldspar, and more combination of them. Okay, so yeah, that is for heterogeneous mixture. Then we have homogeneous mixture, which is called a solution. So a solution exhibit a uniform composition and appears visually the same throughout. Okay, first example, sport drink. Yeah, maybe you like to drink sport drink. Okay, it consists of water, um, sugar, coloring, flavor, electrolytes, yeah, mixed together uniform. Though maybe uh, when you just let it, you just put it, maybe you let it down to be hours, then there will be a little separation that it will not mix uniformly again. But the first time, it will be homogeneous mixture. Okay. Second example, air, maple syrup, gasoline, solution of salt in water is basically homogeneous mixture. Though maybe they also can separate after some time, with one part will be more condensed than other part, but still this is a homogeneous mixture. Okay. So this is the summary of how to distinguish between various major classification. I want you to take a screenshot of this because this is the point of our lesson today. Okay, so matter, does it have properties and composition? Yes. Then it has a constant properties and composition. Yes, that it is pure substance. But if it is no, then the answer will be mixture. Per substance, can it be simplified chemically? Yes. Compound? No. It's just basic element. Mixture, is it uniform throughout? Yes, then it's homogeneous. And if not uniform, then it is heterogeneous. Actually, homogeneous and heterogeneous also exists in many smaller categories. We'll have maybe one chapter discussing about this later. Okay, but I will not put it all today. Okay, so the mass of an object is a measure of the amount of matter in it. One way to measure an object mass is to measure the force takes to exert the object. So, because you know that F equals ma, that's physics formula. Then if you want to know the mass, just m equals F over a, right? A more common way to determine the mass of an object is to use a balance. Yeah, to use a balance to compare its mass with a standard mass. Yeah, there are many kind of balance, right? Although it is related to mass, it's not the same thing. Yeah, this is actually also a very important notion in physics. Actually, chemistry also have this kind of notion. Okay, so weight refers to the force, yeah, that gravity exerts on that object, yeah, because weight W equals m times g. G is the gravity constant. Okay, the gravity acceleration on it. Okay, so this force is directly proportional to the mass of the object. Yeah, but weight of an object varies as the gravity changes. Yeah? It varies with position, but the mass will not change, will never change. For example, an astronaut mass doesn't change because of she going to the moon. Yeah, because yeah, he just have yeah, the body will be the same either that he's in moon or uh he's in he's on the earth, he's on the moon. It will be the same. The number of molecules of his body will always be the same, but his weight on the moon is only 1/6 of his earthbound weight because the moon gravity is only 1/6 that of the earth's. Yeah, why I mixing her and he and she here? Yeah, let's assume the astronaut is a man. Okay, he may feel weightless during his trip when he experiences negligible external forces, yeah, which is we call zero gravity, right? Okay, gravitational or any other, yeah. Although he is, of course, never be massless, yeah. So you may have zero weight, but you never be zero mass, yeah. You are not a photon. If you are a photon, you are massless, but you are not a photon, so you have mass. Okay, so the last slide, I think, yeah. The law of conservation of matter summarizes many scientific observations about matter. Yeah. This basically states that there is no detectable change in the total quantity of matter present when matter converts from one type to another, okay, or change among solid, liquid, gaseous state. Okay. First example, during the brewing of beer, the ingredients water, yeast, grains, malt, hops, sugars, maybe many more are converted into beer. Yeah, water, alcohol, carbonation, flavoring substances with no actual loss of substance. It's just the same. The mass stay the same, but maybe it changed the form, it changed the state. Yeah, maybe you have new compound, yeah, etc. Okay, the color will also be different. Okay, Second example, in lead acid car battery, the original substances lead oxide, and sulfuric acid, which are capable of producing electricity, are changed into other substances, lead sulfate and water, basically, yeah, that do not produce electricity with no change in the actual amount of matter. Yeah. So what changes only first the kind of substance. Second, uh, the ability to produce electricity. That what matters. Okay. Yeah. So we have reached uh, final part of our lesson today. Here's a little assignment. Actually, not assignment because I haven't discussed anything about calculation. Okay, so that's the assignment. Yeah, search on any browser that you have: Google Chrome, Mozilla Firefox, Opera, Safari. Okay, an IUPAC periodic table of the element sheet, like this one you see on the slide, and print it out. Yeah, you'll need it later in maybe the third or fourth lesson. We'll start using this. Okay. The tablet must be the newest version. I always remind you, you have to print the newest version. Maybe the time that this video released and the time that you watch, you already have newer version than this one. Print it out, okay? Because there will always be regular updates from IUPAC committee about the elements name. I want you to always have the newest, okay? There are 108 elements, okay? Okay, so a little inspiration for you today. Charles R. Swindoll once said, life is 10% of what happens to me and 90% how I react to it. So always try to find new things to do, enjoy new things, start your adventure. Don't just be passive, sitting and waiting for anything come to you because you lost many of opportunities and chance to grow yourself. Okay? Yeah, that's being said. Thanks for watching, and here your to-do list. Subscribe, give a like, comment, and share this video. I'll see you next tutorial. My tutorial will be on every Tuesday, Thursday, and Saturday. So keep watching and be thoughtful. Bye bye.